Okay, yeah. So, hello and welcome everyone to the fourth lecture of our CUDA programming. So, yeah. So far we saw, like in the previous lecture, we saw that how we can use like CUDA malloc and CUDA malloc for allocating the memory on the GPU, and CUDA memcopy for transferring the data between CPU and GPU using a typical small program which using which we wanted to initialize the array on GPU using the squares of the numbers from 0 to 99. And yeah, then after we saw a typical CUDA program flow in which we saw a typical CUDA program flow in which there was a couple of steps involved in it. First of all, we copied the data from uh, file system to the CPU DRAM, and then we moved the data from CPU to GPU's DRAM, and then we did specific computations, specific computation on GPU using kernel call, and then we again pushed the results back from GPU's DRAM to the CPU's DRAM, and then we printed the results on the CPU. Yes, so that was the typical CUDA program flow that we saw in the previous class, and then we saw the couple of examples. And at the end, we saw this slide, right? We ended here that we want to write a CUDA program which initializes the array of size 30 to all 0 in parallel, and then we changed the size of array to from 32 to 1024, and then added I to each element. Added I to each arrays. Um, each array is a particular index to, we added I to each index location in that array, and yeah, so we saw that, yeah, that program was working, but as soon as we changed that 1024 to 8000, that second parameter in the kernel launch, we saw if we change that to 8000, the program won't work, because as I stated in the previous class, that there is something called as uh, thread. There is something called as block, and the typical size of that block the number of threads in that block cannot exceed than 1024, and yeah, so that is where we left yesterday. And for today's lecture, I'm planning to cover the thread organization, and so particularly how the threads are organized on GPU, and then we'll see a couple of applications, one-dimensional and two-dimensional, how the one-dimensional and two-dimensional applications can be written using that thread organization that we are going to see. And then probably if we get time at the end, we'll probably also see matrix squaring, but yeah, that depends upon the time. And yeah, so let's begin. So in a particular, so we saw that, like how in previous lecture we saw like how we can launch the kernel using multiple number of threads. And so one thing that we should know here is that when we launch a kernel, it's launched as a grid of threads, and this grid is a sort of three-dimensional data structure. You can see as a three-dimensional data structure. Think of it like a rubric cube. Like if you see a rubric cube, it's like a cube, and inside in that cube is made up of multiple small cubes, right? So think of the grid as something sort of a rubric cube, and this grid has threads inside it, but there is something more to it. So yeah, as I said, that this grid is a three-dimensional data structure, and one more thing is this grid is made up of thread blocks, uh, much in similar way as that rubric cube is made up of that small cubes. Think of a rubric cube as a grid, and that small cubes with which it is made as a thread block. So we have a grid which is made up of multiple thread blocks, and this grid is a three-dimensional data structure. So in order to identify a particular thread block inside a grid uniquely, we need its to identify the thread block uniquely inside this grid, we need its x, y, and z coordinates, which are given by block id x dot x, block id x dot y, and block id x dot z. And since there are three dimensions to the grid, there are x, y, and z dimension. They can be accessed using griddim.x, griddim.y, and griddim.z. So again, grid is a three-dimensional data structure. Its x, y, and z dimensions can be obtained by griddim.x, griddim.y, and griddim.z. And in order, and I mean, as the grid is made up of thread blocks, in order to identify each thread block uniquely inside the grid, we need block ID x dot x, block ID x dot y, and block ID x dot z. Okay, I think we are clear up till now. And next, as I told that each, I mean, grid is made up of thread blocks. And okay, so what is thread block? So thread block is again a three-dimensional data structure, and this thread block consists of threads, and again the threads are arranged in three dimensions: x, y, and z. So coming back to our rubric cubes analogy, think of, I mean, grid is a rubric cube, thread block is a that small cube with which the rubric cube is made, and thread is something which is, I mean, the material inside that small subcube. So okay, so thread block consists of threads, and typically threads are arranged inside a thread block three-dimensional data structure. So I mean, as a thread block is a three-dimensional data structure, it again has three dimensions, x, y, and z. And in order to access each of its dimension, we need we can access it using block dim x dot x, block dim x dot y, and block dim x dot z, which will give all of its size of all of its three dimensions. And yeah, and so as I told that thread block has multiple threads inside it. um, each thread each thread inside that thread block can be uniquely identified with again three parameters or three coordinates: x, y, and z, because thread block is a three-dimensional data structure. So accessing a thread inside that thread block, we need its x, y, and z coordinate, and that can be accessed using something called as thread ID x dot x, thread ID x dot y, and thread ID x dot z. Okay, so I'll pause here for a couple of seconds, and if you people have any question, you can post it on chat regarding this slide. Sorry, yeah. Any questions so far? Let me see. I mean, do we have? Yeah, I guess we have many participants. Yeah. Can you give a recap on kernel? Okay, so I mean, uh, you are telling how to launch a kernel. I kind of cannot understand your question. Like kernel, are you asking, your question is like, sir, what is the maximum number of blocks possible in 1024 core GPU? It is, I mean, it is a very hardware dependent question, and the different GPU might have different limits on the number of blocks that it can, I mean, with which it can be launched. The kernel with which, I mean, the number of blocks inside a kernel are typically different for different GPUs. Yeah. I mean, can you explain?
Where can we get that information? That's what I'm asking.
Yeah, you can refer to NVIDIA's documentation. Probably you will get something from there.
Okay. Thank you.
Yeah, but it's very, I mean, GPU specific, I mean, particular GPU specific question. But I mean, meaning it is dependent on that particular GPU, is what I'm saying. I mean, can you explain what is a kernel, sir? Okay, so kernel is think of it as a function, normal function, but that is, I mean, it's a function which will be executed on GPU. Like you might have seen CPU functions till now, which are executed on the CPU's core, but GPU is a sort of function. I mean, kernel is a sort of function which will be executed on the GPU. So that's a very simple definition of a kernel. Okay, so any questions up till now on that slide? Otherwise, I'll just go on. No, it's not similar to the GPU's kernel. OS's kernel. OS kernel is a different. OS kernel is the part of the code which is part of the OS's code which is loaded in the main memory, and that code is responsible for managing multiple things. Yeah, but this kernel is different. Yeah, so don't confuse that kernel with this kernel. Yeah, so okay. Okay, if there are no questions further, then I'll switch back to the slides, and yeah, I'll turn off the video for now to save the bandwidth here. Yeah, that's fine. Okay, let's get back to the slides. Okay, as I mentioned that grid consists of 3 dimensions, x, y, and z, and then grid is made up of thread blocks, and each thread block again has 3 dimensions, x, y, and z. So one question that you might ask that can't we have less than 3 dimensions? Yeah, that's a very valid question, and the answer to it is like we can even have a thread. We can even launch a grid which is not, which doesn't have x, y, and z dimension. Grid can have just 1 dimension also. In the similar way, a thread block can just have 1 dimension, but at max we can have 3 dimensions. So grid can have any dimensions ranging from 1 to 3. Similarly, a thread block can have any dimensions ranging from 1 to 3. And in case if any of the dimension is missing, like let's say we just want to launch a grid with 1 dimension, and there are no second and third dimension, in that case those dimensions will be 0. So yeah, so there is a possibility that we can just have 1 dimension or just 2 dimensions for any of grid or the block. So that is one point that I want to make out. The second point is, yeah, so let's come to the second point. It's actually a question. Hello. Okay. So yeah, so let's come to the second point that I wanted to ask. So the second point is like, let's say the dimension of the grid in x direction is 10, and dimension of grid in the y dimension in y direction is let's say 5, and in z dimension it's 7. Then what is the value of this block id x dot x dot y and dot z? What are the range of values that it can take? I want each and every one of you to type your answers in chat. Okay, let me go to the chat. So my question is grid dim dot x equals to 10. Then, and similarly dot y equals to 5, and dot z equals to, okay, let's keep it 6, and and dot z is 7. And what can be the range of values that block id x dot x dot y and dot z can take? Can anyone post the answer in the chat? I request each and every one of you to think about it, and let me know the answers in the chat. Okay, I'm going back to the chat. Yes, that's correct. 0 to 9, 0 to 5, and 0 to 6. Yeah, 0 to 9, 0 to 5, and 0 to 6. Yes, that's correct. It will be thread id x dot x, not grid dim x. So grid dim x is a dimension, so it's like a size, so its value is fixed. Its value is 10, but thread id x dot x can go from 0 to 9. So I just wanted to clarify that, Ramasamy. And Yeah, Brynmoy is saying yeah 0 to 9 for X. I think you people are correct. I request each and every one of you to try so that we can have clarity. Someone has raised the hand. Uh, if you have any questions, you can directly unmute yourself and ask. Okay. Okay, I guess 0 to 9. Yeah, I think you people are understanding it properly. So let's get back to the slides. Okay, since X dimension has size 10, so block ID x dot x can go from 0 to 9. And since Y dimensions size is 6, as in our previous example, block ID x dot y can grow from 0 to 5. And similarly for Z, it can go from 0 to 6 because its size is 7. So I think you will got it. And yeah, one more point that I wanted to make was like, even we have this 3 dimensions, we can just use 1 dimension out of this 3 dimension and make all our application work. Yeah, so that was the second point. And yeah, so I'm moving along the slides. So typically putting this in a pictorial point of view, as a picture, uh, so we have this CPU side, right, where we have, the host is launching the kernels, and this is the timeline. So at this point in time, the kernel 1 was launched by the host, and then the kernel 2 was launched. And as I said, kernel can be launched. Thread can be of any size. It can be two. It can have any dimensions from 1 to 3. So it in this case we have launched a thread with 2 dimensions where x dimension has size 2 and y dimension has size 2. And okay, so as the grid is 2 cross 2 in the dimension, in the size, so each block inside a grid can be accessed using can be identified using block id x dot x and block id x dot y. So in order to identify a particular block, we will need two values, which is block id x dot x and block id x dot y, and that both value can uniquely identify a particular block. So let's say this block, if we want to identify it, then we'll look at block id x dot x and block id x dot y, and we'll get that both the values are 0. So this block is 0 comma 0. Similarly for this block id x dot x is 1 and block id x dot y is 0. So it's block number 1 comma 0, and so on for the rest of the blocks. And as I said, each block can be each block again has 3 dimensions. It can also have 1 dimension or 2 dimension, but in this case it has 3 dimensions. So since it's a 3-dimensional block, threads inside this block are arranged in 3 dimensions: x, y, and z. X, y, and z. So in order to identify a particular thread inside this thread block, we will need 3 coordinates or 3 parameters, and that 3 parameters will be given using thread id x dot x, thread id x dot y, and thread id x dot z. So pictorially you can see how a particular block is projected here. And in this first thread, which you can see here, has thread id x dot x as 0, thread id x dot y as 0, and thread id x dot z as 0. Oh. Does anyone have any question? Hello? Okay, I guess it was some noise then. So okay, so a particular thread can be identified using its x, y, and z id, and that was what we saw in the previous slide, and here it is represented pictorially. So well, that's okay. And again, after a particular point in time, our host or CPU is launching another kernel which has 3 dimensions, uh, x, y, and z. Which is a 3-dimensional grid. Which has x, y, and z dimensions. So in order to identify a particular thread block inside that grid, we'll need 3 dimensions: block dim x dot x, block dim x dot y, and block dim x dot z. So yeah, I think the point is clear here, that grid can have, the grid can have 3 dimensions, and a particular thread block can have again 3 dimensions. It can have less than it, but yeah, maximum is 3 dimensions. And based on the dimension of grid and the dimension of thread block, we'll need different parameters for identifying the thread block and thread inside the thread block. So okay, so with this I'll move on. And yeah, so again, this is sort of a recap. So in order to identify the thread block, we'll need, each thread block can have 3 dimensions. And each thread block can either be of 1 dimension, 2 dimension, or 3 dimension, depending upon the size of the grid. And each thread block can have threads arranged in 1, 2, or 3 dimensions based on the number of I guess there is noise from someone's end. Can please, hello, can you please mute? Okay. I request each and every one of you to mute unless you have any question. Otherwise, we will have lot of such interruptions. Okay, thanks for muting. I'll come back to questions, but let me switch to slides first. Okay, so the point that I was trying to make here was thread blocks can have, thread blocks can be of 1 dimension, 2 dimension, or 3 dimension, depending upon the size. Depending upon the dimensions of the grid. And each thread can, each thread can be arranged. Threads can be arranged in 1 dimension, 2 dimension, or 3 dimension, depending upon the dimension of a thread block. And yeah, again, so one more question here is like, if we can, as I said earlier, instead of using 3 dimension, we can use just 1 dimension, and that will work perfectly fine. But why do we need this 3 dimensions then? So in some particular applications, having this multiple dimensions and arranging the threads in this 3-dimension data, 3-dimensional data structures, and is sometimes helpful, such as in image processing application. If you want each and every thread to be associated with a particular pixel, and like let's say the image is a colored image, then in that case it's a 3-dimensional like tensor, some sort of tensor. Then in that case, we want each and every thread to be associated with a particular cell, or a cell in that 3-dimensional matrix. Then in that case, the ID calculation will become very simpler, and we'll see some of the examples later. And the second example is while solving partial differential equations on the volume. So in that case also we have multiple dimensions and all those things, and handling and ID generation becomes simpler if you use 3-dimensional threads and 3-dimensional thread blocks. So yeah, that's it. And okay, so coming to the next point, so in a typical CUDA program, you will see these configurations that are mentioned here. So each thread block will be 1 to 5 thread blocks will be allocated to a particular streaming multiprocessor. So what is streaming multiprocessor? First of all, SM stands for streaming multiprocessor, and think of it like this: we have this GPU, and each there are 15 to 25 streaming multiprocessors inside the GPU, and each streaming multiprocessor can have somewhat like 40 or 50 cores inside it. So yeah, so that is what is streaming multiprocessor. So GPU is composed of streaming multiprocessor, and each block, a particular block, when a kernel is launched, a particular block is assigned to a particular streaming multiprocessor. So yeah, so that's what I was trying to that's what I was trying to say. 1 to 5 blocks are assigned to a particular streaming multiprocessor, and in particular there might be 128 to 1024 thread blocks in a threads in a particular thread block, and in total your application might have some 2k to 100k threads, and these are typical numbers. So I mean, this is what generally is observed, and in general it's I mean, it seems, I mean, we can see that we can launch a kernel with millions of threads. Okay, so I'll pause here for some second, and we'll go to the chat to see if you have any questions here. Please explain grid dim X. Okay, so okay, Deep. So grid dim X is like you can think of it like the X dimension of your grid. So grid is a three-dimensional data structure, as I explained, and the X dimension of that grid is given by grid dim.x. I hope that answers your question. Okay. Okay, so moving on to next question. Sir, I am unable to use Google Colab. There is a video which demonstrate how to use Google Colab. Lakshya Raj. In the sheet we have that video. Please go through that video. And if you have any questions, then post it in the group or you can mail me. Okay. Grid is also 3D. Am I right? Yes, grid is a three-dimensional data structure. And I wanted to know typical configuration of number of grids for understanding. Typical configuration of number of grids. Blocks and threads are clear in your slide. Okay, so grid, I mean, think of it like a single big data structure. There is, I mean, if you launch multiple kernels, then there will be multiple number of grids. But for a particular kernel launch, there is only a one grid, and inside that grid there are multiple thread blocks arranged in three-dimensional or two-dimensional or one-dimensional, depending upon the dimension of the grid, number of the dimension of the grid. And threads is clear. Okay, I hope that was clear, Ramasamy. If it's not clear, then you can unmute and ask. I mean, there is no, I mean.
Okay, so fine.
Okay. Okay, thanks for confirming. Is there any fixed formula to get unique thread ID? I saw few formulas around, unable to confirm the right one. Okay, so yeah, that's actually a good question. So to calculate a unique ID using this grid dim, I mean grid dim and dot x and all those things that we saw in previous slide, there are a couple of formulas, and it depends upon the number of dimensions that you are using. So let's say you have two-dimensional grid and let's say three-dimensional thread block, then you need to use a different formula as compared to the case when you have one-dimensional grid and one-dimensional thread block. So we'll see a couple of formulas in this slide, and we'll also try to understand them. But yeah, I mean, there is one fixed formula for a particular configuration, I would say. Like, let's say you are just using one-dimensional grid and one-dimensional thread block. In that case, you will get a one fixed formula. But for different configuration, I don't think that formula will remain the same. I hope that answers your question, Velumani. Then, what was the role of SM? Okay. Okay, so think of SM as some sort of core. I mean, SM stands for streaming multiprocessor. So think of it as a one core inside which there are I mean, not a core, like it has multiple core inside it, but think of it as a unit which hosts the multiple cores of the GPU. In that way, you can take, like, it's a one unit inside which it can have multiple cores. And what was the role of it? So the role of it is like each streaming multiprocessor will be assigned multiple thread blocks. So that is what is its role. I mean, the role is its role. I hope that's clear, Gurkiran. Deep sir, is this tensor same as the matrix tensor used in deep learning? Uh, okay. The what I was talking about was like uh, three-dimensional matrix sort of thing. For like in colored image we have this RBG, right? So we have uh, X and Y dimension, and the third dimension is that color dimension. So I was talking about that, and I don't know if that is very similar to this deep learning tensor or what. But I don't know about it. I need to look into it. But the one that I was telling in that example was this three-dimensional matrix. Think of it as a three-dimensional matrix. Okay, Lakshraj is saying I have also watched your tutorials. Okay, in that case you can just post your post your error in the Google group, or you can also mail me with your errors. Voice breaking now and then. Each block has 1024 threads. Okay. Okay. I guess everyone. I am hoping that everyone is with me. And in that case, let's continue with our slides. And in case you have any questions, you can just unmute yourself and ask. But let's move on further. So we saw all this, right? Griddim.x and griddim.y and all those stuff. Now let's see how to access these dimensions inside a kernel or GPU, GPU kernel. So for that, I'm launching a kernel, but first of all, I'm defining a grid and a block. So here you will be able to see that I've declared something. I have this dim3 something. So what is this? Take this as sort of a data type, and then I have written this grid. So this grid is just an identifier. You can replace it by any other name. So I'm declaring a sort of a variable which has three dimensions, and it's all these three dimensions are specified here. So this 2 is x dimension, 3 is y dimension, and 4 is the z dimension. So I have declared something called as grid, which has 2 as its x dimension, 3 as its y dimension, and 4 as its z dimension. Then I'm also declaring again something called as block using that same data type dim3 with x, y, and z dimension as 5, 6, and 7. Cool. Now I'm launching this. Now I'm launching a kernel with grid comma block with grid and block as the parameters in it. And yeah, after that I have CDS, CUDA device synchronize, and then we are returning. And then okay, so then coming back to the kernel part, inside the kernel I have written this thread id x.x equals to 0. I have written this condition which says that if thread id x.x is 0 and block id x.x is 0, similarly for y and for z, if this condition holds, then I'm printing this dimensions x, y, z for the grid, and for the block again x, y, and z. So I have two questions for you people here. First question is with how many threads will this kernel will be launched? That is the first question. And the second question is like what will be the output of this program? How many lines will be printed, and what will be what will be those lines? Okay, so I'll pause here for a couple of seconds or probably a minute for you people to try out, and after trying, please post your answers in the chat so that we can understand like how we are progressing.
I have a quick question, sir.
Yeah, please go ahead.
So, I am confused with the terminology here, given that we understood the first term as block and the second being threads. Here it is grid comma block. So the first, before you used to say that the first is the block, which says that how many, um, uh, essentially you can access a block index within that. And then for given each block, you can have a lots of threads, a three-dimensional thread structure within that.
Yes.
So the first term, is it signifying of a block? Because one more follow-up question on that. Um, is one grid assigned to one kernel? Is that the correspondence always? Yeah.
Yes. Okay. So I'll take one by one. So first question was like, so you told that the first parameter denotes the number of blocks, but I am telling that here it's grid, right? I mean, so that was your first question, I guess. Am I correct?
Yes.
Okay. So take it like this. Grid is just a name, and grid is composed of the blocks. So here I'm writing grid. So it means that and okay, so let's understand why am I so first parameter denotes the number of thread blocks, which is correct, but I think you are confused with it because I have written here it as grid. So when I say this grid has dimension 2 comma 3 comma 4, take it in that way that I'm launching this kernel as a grid, and inside that grid it has it's a grid with 3 dimensions, where x dimension is of size 2, y dimension is of size 3, and z dimension is of size 4, and it's made up of thread blocks in those 3 dimensions. Take it in that way. So
Okay, got
yeah, I hope that that's clear, but
Yeah, that's
just to make it more clear, I would say that this is just a name. So don't go by what it is written here. Uh, this first parameter still denotes the number of thread blocks. And the number of thread blocks with which this kernel is launched, can you quickly tell how many thread blocks with which this kernel is launched? Just to confirm your understanding, I'm asking you.
So the first thing will be 2 into 3 into 4, 24
Yes, yes.
blocks
So
will be launched, and within that
yes,
there will be thread. Yeah.
yes, correct. So this is just a name. It's saying that we
Correct.
are launching the kernel with 2 into 3 into 4 blocks, and this is again a name which is saying that it's just saying that yeah, this is a block, but it's essentially saying that inside each block we have 5 into 6 into 7 threads. So just don't go by the name.
Understood.
It's denoting the number of threads inside the block, and this is the number of blocks.
Sir,
And yeah,
we have, you said like two into three into four, right? Why are we like declaring it in that format instead of as opposed to like giving just 24 directly, sir?
Yeah, that's a good question. So it can be done in either way. We can just write here 24 instead of this three-dimensional, declaring it as three-dimensional. But the reason I'm doing it here like this is that if we just write here 24, then the kernel will be launched with just one dimension. So grid will have just one dimension, and that one dimension will be the x dimension, and that at x dimension will go from 0 to 23, and there will be no y and z dimension. But in order to access all the 3 dimensions here, I am declaring the grid as 2 comma 3 comma 4, so that our kernel is launched as a grid with 3 dimensions, x, y, and z. If I don't do this, it will be launched as just a single dimension grid. I hope that you are getting it.
So like
But
in the
both,
future we could like use each dimension for like different tasks or like that something.
yes, you can use that each dimension for different tasks. Like as I mentioned, for image processing applications, you can use each dimensions to assign to a particular portion of the image or something like that you can do.
Yes, sir, that is right. For image processing, the kernel, we want a spatial feature. We don't want to lose that.
Yes. So that is why this flexibility is given by CUDA. But in case you don't want to specify like this 2 comma 3 comma 4 and then launch it as a 3 dimension grid which is of 3 dimension, you can just launch it using just by writing here 24, and that's fine. There is no performance penalty or any such thing, but it's just for the convenience. Hello. There is a lot of noise from someone's side. Okay. So my question was, I'll probably repeat the question if someone would have missed. So I mean, so how many threads will be launched and what will be the output of this program was the question. And quickly, I guess we have, I mean, yeah. So let's go back to the chat and see what you people have answered. 2 into 3 into 4 into 5 into 6 into 7 is the kernel dim. Okay.
Thread, number of threads.
Yeah, it's a number of threads. Yeah, it's not kernel dim. It's the number of threads with which the kernel will be launched. That's correct. Launched with 5040 threads. Yeah, 7 factorial is the number with which the kernel will be, number of threads with which the kernel will be launched. And it will print only 0, 0, 0, 0, 0. Okay, we'll see that. 2 into 3 into 4, 5 into 6 into 7. Okay. Output is 2, 3, 4, 5, 6, 7. Okay. Yes, only one print will be executed. Yeah, I want each and every one of you to think how many printfs will be there. I mean, how many lines will be printed. So far, I can only see like one person replying for that. Okay, one print. Okay. Okay, one print. Okay, good. I mean, you people are trying. That's good. Okay, and 5040 will be kernel size. Okay, good. Okay, so let's go back to the slides. I guess you people are correct. I mean, most of you are correct. So, yeah, let's try. And I mean, most of the time I'm able to only hear your voice. I mean, noise. Okay. What you can do is you can type in chat if. Yeah. Okay. So what I suggest is you can type in chat whatever your doubt is. Until that issue is. Yeah, you can type in chat. Yeah. Okay. So meanwhile, I'll go back to the slides. Venumani, you can type your question in the chat, and I'll come back to the chat after a couple of minutes. Okay, yeah, so like since the grid is three-dimensional with x, y, and z dimension as 2, 3, and 4, and block is of again 3-dimension with x, y, and z dimension as 5, 6, 7. So kernel will be launched with 2 into 3 into 4 into 5 into 6 into 7 number of threads, which is 7 factorial threads, or 5040, I guess, number of threads. And see, once the kernel is launched, let's try to see what this condition is doing. So this condition is saying that the thread with xid. Okay, so first of all, it's saying that I want to go to the block which has x, y, and z coordinates as 0, 0, 0, and inside that block, I want to go to the thread which has its coordinate as x, y, and z coordinates as 0, 0, 0. So what will happen is we will get a unique block, and that too inside inside that block will point to a unique. Okay, so inside each, so we have each, so for each block, for a particular block with ID, XID, YID, and ZID as 0, we'll be able to uniquely identify that block, and inside that block also we are uniquely identifying a particular thread with X, Y, and ZID as 0. So only one thread will pass this condition, and that thread will print uh, x, y, and z dimension of grid as well as x, y, and z dimension of that thread block, which is 2, 3, 4, 5, 6, 7. So a single line will be printed, which is 2, 3, 4, 5, 6, 7. And yeah, that's okay, and that confirms our understanding. The next question that I have for you people is let's say I removed this, I removed this condition, this condition, block ID x dot x equals to 0. Then in that case, how many printfs will be executed? How many lines of printfs will be there is my question. Let's say I remove this block ID x dot x equals to 0, I remove. In that case, how many prints will be there in R? I hope every one of you, each and every one of you are trying. And first of all, you people got my question and are trying. Okay, so moving back to chat. Okay, 211. Same like the only thing is we are checking that condition. Okay. I request all of you to try. I'll just switch back to the slides and wait for few more seconds for others to try. Okay, let me see what you people are answering. 211, same like the only thing is we are not checking that condition. 5040 by 2 7 factorial 52. So I type my question, kindly check. Okay, I'll go back to your question, Mani. Just give me a moment. Bye. Okay, so first of all, okay, let's go back to this slide and let's try understanding it. So if I'm just removing this block ID x dot x, then what will happen is, okay, so I'm not checking the x dimension of the block, and if I'm not checking that, then what will happen is the blocks with having which are having y and z dimension as 0, but any x dimension, they will pass this condition, right? So blocks which have y and z dimension as 0 and any x dimensions will be 2, right? Because we have 2 blocks in x dimensions, because grid is having x dimension, size of x dimension as 2. So there will be 2 blocks which will have y and z dimension as 0, but x dimension can be any, it can be 0 or 1. So there will be 2 such blocks, and inside such blocks, 2 such blocks, we want the thread which has x, y and z dimension as 0 0 0, and there will be only one such thread inside both of this block. So there will be 2 lines of printf after this thing is removed. Block id x dot x equals to 0 is removed. There will be 2 lines of printf, and both of them will print the same thing: 2 3 4 5 6 7 and 2 3 4 5 6 7. Twice it will be printed in 2. There will be 2 lines of the output. So I hope that is clear. And one more thing is, the one more question that I wanted to ask. Let's say instead of this entire if condition, I just removed everything that is there in this if condition, and I just replaced it with one single thing, with just one check, which is this thread id x dot x equals to 0. I just wrote this thing and removed everything else. Just removed all these things and just wrote this thread id x dot x is 0. then in that case, what will be the output? I request each and every one of you to think about it and post your answers in the chat. It's important that we do this so that we can understand this dimensions and all those things better. So my question again, I'm repeating. We are just adding this thing, thread ID x dot x equals to 0, and removing rest all of the things. Then how many lines of outputs will be printed? Just don't worry about what will be the output in each line, but how many lines will be there in the output is my question. Okay, meanwhile, I'll take up some questions. I think, yeah, some must. Okay, sir, my question is, I should know the total thread requirement. I should know the total thread requirement. I am not using mail ID for attending the class. Please tell, okay, how the attendance is considered. Okay, well, I mean, please give your email to, please mail your email to me. I'll take care of it. Okay, so I should know the total thread requirement so that I can split the different access in DIM3 element, right, sir? Yes, you should know the thread requirement. But in case even if you don't know the thread requirement and if you are splitting, that's also okay. You can just assign multiple tasks for each thread. Here, DIM3 blocks 2, 3, 4. These combinations can be written as 3, 4, 2. Is there any difference, sir? There is. I mean, there is no difference in terms of the number of thread blocks with which the kernel is launched, but the dimensions of the grid will differ. That is the only difference that we'll have. I hope that's clear. And to calculate thread requirements, I should be aware of computational load, maybe task size, sir. Yes. Is there any way to understand this in a better way? Okay, so for understanding the computation load, you need to go to, I mean, you need to understand your algorithm again and see how much amount of parallelism or how much amount of parallelism that you have in it, and what is the chunk of the work that can be divided across the multiple threads. And in that way, you can just have a rough idea of how many threads with which you want to launch the kernel. And based on that, you can decide the 3 dimensions of the grid. I hope that's clear, Velumani. Okay. Hmm. 7 factorial by 5, 2, 3, 2 into 3 into 4 into 6 into 7. That's correct. 7 factorial by 2, 1008. I'm not sure if the multiplication is okay. I will look into it. 3 into 4 into 5 into 6 into 7. 1008 times 46 prints. Okay. 74. Understanding algorithm is very important again. Yeah, okay. Yeah, that is important. Otherwise, I mean, how will you know the amount of parallelism that you can extract out of it? And that will determine the number of threads. Okay, 1080, 7 factorial by 5. Okay, I can see that most of you are correct. But let's go back to the slides and let's try understanding what will happen actually. So, as I told, if I only mention this thread ID x dot x, then what will happen? And I mean, we are removing the rest of the stuffs, right? So what will happen is, so first of all, now this condition will not restrict the threads of the, I mean, other blocks. I mean, the the threads which are there in other blocks won't be restricted as it was in the previous case. So inside each thread block, the thread having ID its x coordinate as 0 will pass the test, right? Will pass this if condition. So we should think how many threads are there. Well, I mean, how many threads are there across all the blocks which are having its xid as 0. And one thing you should observe that inside, I mean, such number of threads will be 2 into 3 into 4. I mean, the number of grids, the number of thread blocks into 5 into 7. Because if x dimension is 0, I mean, the thread with xid as 0 will be 1 for each x coordinate in a particular thread block, right? So this will be 1. And apart from that, will have, I mean, there will be such one thread for each x dimension, and such 6 into 7 dimensions will be there inside each thread block. So the total number of threads which will satisfy this condition, this alone condition, will be 2 into 3 into 4 into 6 into 7. So that many times the printf will be executed. I hope that's clear. If you have any questions, then please you can, I mean, unmute yourself and ask immediately.
Yes, sir.
Yeah, please go ahead.
So can you explain this problem in the previous video? I didn't understand.
I mean, by previous problem, which one you mean? Can you please explain?
By previous problem, I mean the one where you remove only the thread IDX and the block IDX.
Okay, so in previous problem there this was removed. Block ID x.x was removed. That one, right?
Yes.
Okay, I'll try to explain you again. So let's say if I remove this block ID x.x, right? So in that case, what will happen? So uh, like now what we are doing is we are uh, restricting. I mean, what we are doing is we want all the thread blocks with. We don't care about the x dimension, but its y and z dimension should be 0. So such number, I mean, such thread blocks will be only 2 in number because uh, we have this x dimension as 2. So there will be 2 thread blocks with uh, x dimension as 0 and x dimension as 1, and y and z dimension will be 0 for that block. So there will be 2 such thread blocks, and inside that each thread block, the thread with x, y, and z dimension as having, I mean, inside that each thread block, the thread having x, y, and z dimension as 0 will be only 1. So there are 2 thread blocks. Inside that there is one thread which satisfies this condition. So there will be 2 printfs. I hope that's clear. If there is something unclear, then you can unmute and ask for this question. I mean, for this part, I'll also explain the next one that you asked.
Can you show this answer pictorially also?
Pictorially, it will be very difficult for me to draw. Okay, but let's take this offline, Alex. If you are still confused, then we can probably
Okay, sir.
get over a mail, because I mean, if you are drawing, it will take
You
a
say your
lot.
voice is breaking down.
Hello, is it clear?
Yes, sir. That's it.
Yeah, so what I was telling is pictorially drawing it will be time consuming as well as, I mean, difficult for me now, but we can take this offline over email or even in the Google group. Uh, yeah, so there we can discuss about it, because I mean, here we'll run out of time unless, I mean, if I start drawing it on picture and all those things. Okay, but we'll take that. You can just ping me after this lecture and I'll try to explain you in the mail. Okay,
Okay, sir.
sure. Yes, I'll quickly switch back to that chat. Okay. Okay, I hope it's clear for everyone.
Sir, could you explain the second one, sir? That we did. It only thread ID x equal to 0.
Okay, yeah, so let's understand that again. So let's say I have just this thread ID x dot x is 0. Now each and I mean there is no restriction on block ID, right? Because we have just this conditional thread ID. So 2 into 3 into 4 blocks will have some threads which will satisfy this condition, right? Thread ID x dot x equals to 0. First of all, you should agree with this, right? So there will be 2 into 3 into 4 blocks which will have some threads inside it where thread ID x is 0. Now the question is, how many threads inside each block? Now 2 into 3 into 4 thread blocks are there, but how many threads inside this each thread block have thread ID x dot x equals to 0? To find that thing, we need to look into this thing. Now how many threads will have its x ID as 0? It will be exactly one thread. And inside exactly one thread, not inside a thread block, exactly one thread in x dimension will have thread ID x dot x as 0, and such 6 into 7 threads will be there, right? Because the dimensions are 5 into 6 into 7, so 6 into 7 threads will be there which will have its thread ID x dot x as 0 inside a particular thread block. And such 2 into 3 into 4 thread blocks are there, and hence the answer is 2 into 3 into 4 into 6 into 7. So this many thread blocks into 6 into 7 threads in each thread block having thread ID x dot x as 0.
Sir, in the end, would we have to do like +1 because in the first block we have 1 now, sir?
Plus 1 first block, I didn't understand your question. Can you elaborate?
Sir, in the x dimension there is like 5 threads now, sir, per block. In that you said we had 1 now, sir.
Yes, we have we have 5 threads, and ID will go from 0 to 4, right? So out of that 5 threads, one will have the ID as 0, second will have ID as 1. So only one thread will be there out of 0 to 4 which will have its ID as 0. So I don't understand the need of doing +1, but as I explained, there is only one thread out of that 5 threads, and such 6 into 7 threads will be there in a thread block, and such 2 into 3 into 4 thread blocks are there. So 2 into 3 into 4 into 6 into 7. So I didn't understand why you are telling +1, but there is actually no need of doing +1. I hope that's clear. I'll quickly go to chat if someone. Okay, I'm not. Okay, so the final answer is for the last question that I asked, the final answer is the number of lines it will print is 2 into 3 into 4 into 6 into 7. I'm not getting any of the Google group updates in my registered email. Okay, probably I'll remove you and add you again. Devendra. Okay, Devendra. Okay, right? I'll do that. Okay. Whether slides are shared in. Slides are added in the sheet that I've shared. So for each of these.
Another alternative ID. The previous ID you said it's not working, so I have added and it confirmed it is working. But I'm not getting any updates.
Okay, one thing I'll do is okay. Again, new ID is not working. You are saying.
Yeah. The new ID you have added and confirmed, but I'm not getting any updates. Is there any mail updates received for the people in the group?
So as far, for now, we don't have any mail updates. Not at least for today, we don't have any mail updates. But just in case you want to access the resources, you can directly access it using the what I can say this Google Sheet that we are maintaining. And one more thing, if you have any questions and if you don't have access to the Google group, one thing that you can do is you can directly mail me. So I'll pick up your questions whenever I'll get time and will reply you for with the answers.
So there are no mails that have been sent before the class.
So before the class, there is, there is no mail actually sent before the class. So no one is getting that mail. So don't worry about that. And regarding the schedule, we have already posted the entire schedule on the website. So yeah, so whenever there is class, it's already written there. So you need to be prepared for it prior. And yeah, there is no email update before the class. There is no reminder or anything. And when you say thread IDX part will be removed, what's the answer? To your previous question. Yeah, so for the previous question, the answer will be 2, as I explained. When just that block, okay, just let me go back. So when this block ID x.x will be removed, the answer will be 2. This part. I hope that's clear. Okay, so that's good. We have a lot of questions, and yeah, so I'll move on further because I still have many things to cover, and probably will miss out many things otherwise. Yeah, so simply the number of threads that will be launched is, as we saw, 2 into 3 into 4 into 5 into 6 into 7. Number of threads in a thread block will be 5 into 6 into 7, and number of thread blocks in the grid will be 2 into 3 into 4. And thread ID in x dimension is from 0 to 5 because thread ID in x dimension is from 0 to 5. Okay, it should be from 0 to 4, I guess. I have written. Okay, yeah. So there is this 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 kind of brace which says that 5 is excluded. So thread ID in x dimension is from 0 to 4, and it's written correctly also. So when there is this this kind of closing brace, it means the last 5 is excluded. So thread ID in x dimension is from 0 to 4, and block ID in y dimension is from 0 to 2, 0, 1, 2. So yeah, that's it from this slide, I guess. And yeah, this thread ID x.x equals to 0 thing we already saw, right? If we replace that entire condition, this entire condition with just this thing, thread ID x.x equals to 0, then we saw that what will happen, how many printfs will be there, right? So that's it from this slide. Moving on to the next slide. Now let us see how this 2D computation is being done on the matrix. So for that, let us take this sample program. We have we have this hash define NSPy and hash define MS6, and we are defining this variable called as block using this team3 data structure with n with x dimension as n, y dimension as m, and z dimension as 1. So essentially we have block with two-dimensional block with x dimension of size 5 and y dimension of size 6. Then I'm declaring 2 pointers, star matrix and star h matrix, which are essentially 2 pointers. H matrix points to the matrix declared on the CPU, address of the matrix declared on the CPU. H stands for the host, which is CPU, and matrix is the pointer which points to the memory, to some memory location allocated on GPU, which is essentially a matrix. Yeah, as I said, matrix points to some memory location on GPU. We are allocating memory using CUDA malloc on GPU, and that allocated memory's address is pointed by the matrix pointer. And similarly, H matrix is declared on the CPU using malloc. Now we are launching the kernel with with the configuration 1, block. So as we saw in our previous discussion, the number of threads with which this kernel will be launched will be 5 into 6, which is 30 threads will be 30 number of threads will be the one with which the kernel will be launched. And we are passing this matrix, which is pointing to some GPU memory location. And then after doing this, after the kernel computation is finished, we want we are copying the matrix back to the H matrix, which is the CPU's CPU declared the space which is declared on the CPU, and using CUDA memcopy device to host, that is from GPU to CPU. and then we are just printing this matrix on the CPU, which is stored inside the H matrix. Now I would like each and every one of you to write the code to initialize the matrix to unique IDs. Again, I want to write each and every one of you write the code inside this kernel part, inside this kernel, to initialize the matrix to unique IDs. So one thing that we should observe here is that even though we are saying it as matrix, it's actually one-dimensional array of size m into n, because it's a vector, not a, it's just one-dimensional array, but of size n into m. So I'll wait for a couple of seconds here for you people to try. And if you people want any clarification, then you can post in the chat. If any clarification is needed, then you people can ask by unmuting yourself, or you can post your questions in the chat. I'll go back to this slide so that you people can try. Okay, I hope that every one of you, are trying at least. Yeah, so matrix of thread ID x dot x into block dim dot y plus thread ID x dot y equals to the same thing. Okay. I think that's correct, but we need to check. We'll see it. And I'll go back to the slide so that you people can see the question. Thread equals to thread ID x dot x, matrix of thread equals to thread. Okay, I think this will fail. Okay, we need to see what will happen now. We are just accessing the x dimension. In that case, many entries won't be initialized, I guess, with this approach. Thread ID x dot x into block dim dot y plus thread ID x dot y. I guess this is correct. Okay, but we'll see. I request each and every one of you to try at least. I mean, even if the answer is wrong, that doesn't matter, but it's important to try. Okay, okay, so switching back to the slides, since we have less time. So, okay, let's try understanding it, what will happen. So, so this is how, this is one of the way in which we can initialize the matrix. So let us try understanding it, what is being done here. So we are generating a unique ID for each thread within a block. So please note that we are just launching a thread with one block, right? So there is just one block, and inside that block threads are arranged in two-dimensional manner, right? Of size, I mean, the block is of two dimension of size n into m, and so there is one block being launched which has threads arranged inside it in two dimensions. And inside the kernel we are generating a unique ID. And how we are generating this unique ID? uh, so first of all, you need to observe that this block dim.y is always constant, no matter whichever thread invokes it. This block dim.y will always be 6, right? Because the block dimension in y direction is 6, so this will be always 6. And now, depending upon the thread, this thread ID x.x and thread ID x.y can vary. So for the first thread, which has thread ID x.x as 0 and thread ID x.y as 0, for that thread, ID will be calculated as 0 into 6 plus 0, which will be 0. So matrix ID, so matrix of 0 will be initialized to 0. Now for the thread number 1, its thread ID x dot x will be 0 and thread ID x dot y will be 1. So its ID will be initialized as 0 into 6 plus 1, which is 1. So matrix ID of 1 will be 1, and so on till the fifth thread. I guess, yeah, and so on till the sixth thread, I guess. For the thread ID x dot x will be 0 and thread ID x dot y will be 5. So 0 into 6 plus 5 will be 5. So matrix ID of 5 equals to 5 will be initialized. And then from the 7th thread onwards, you should observe that its thread ID x dot x will now become 1 and thread ID x dot y will become 0. So 1 into 6 plus 0 will become 6. So matrix of 6 will be 6, and so on. For the next thread, it will be 1 comma 1. So this will be evaluated to 7. This expression will be evaluated to 7, and so on till the 30th thread. And for 30th thread, as you people can guess, this thread ID x dot x will be 4 and thread ID x dot y will be 5. So 4 into 6, which is 24, plus 5, which is 29. So ID will be computed as 29, and matrix of 29 will be initialized to 29. So this is the entire execution flow. And if you see the output of this program, it will be like this. So this printf, this printf here will print this thing: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up to 29, as I explained. So this is how you can you can use this two dimensions n and m of a particular block to initialize a matrix by using the x and y dimensions of that grid. Accessing the x and y dimension of the threads inside that grid. Okay, any questions up till now on this slide? I would like you people.
That block dim.y, it's supposed to find the block number of the current thread, right? The y dimension.
Block dim.y is a dimension. It's the size of that dimension. So when you say block dim.y, it's a fixed number 6. It says that what is the dimension of that block in y direction, and it's 6. That's a fixed number.
Sir, but while declaring, we had given like one-dimensional block with threads of 3 dimension, right, sir? In D
Yes.
kernel initially.
So when we say one comma block here, it means that we are launching the kernel. I mean, we are launching a grid. We are launching one grid with one block, and that block has a dimension 5 into 6. So if you say block dim.y, it will give 6. If you say grid dim.x or y, it should give 1, right? Because we have just one grid. I mean, sorry, we have just one block. I hope that's clear.
Sir, but I thought like the syntax of initializing the kernel is block, comma, threads, right, sir?
Yes, here it's number of blocks and here it's number of threads.
Okay,
Go on
sir.
with
So like when the block, I thought that when block dim is called, it will find like the actual number of block that thread is in.
no block dim. Okay, so I think you are confused here. When you say block dim.y, what it does is for the current block, I mean for uh, the block that is being considered here, it will see, okay, so it will see what is the dimension of the particular block in that y dimension, in y axis. Think of it like that. So here in this case we have just one block, and for that block also its size in y dimension is 6. So this block dim.y will give 6. I hope that's clear. uh, if it's still unclear, then please tell me what's your query so that I can explain better.
I'm just getting confused between the blocks and the grids, sir, because syntax
Yeah,
and the name should be different.
I got it. I mean, it's a bit confusing on the first go, but I request you to go through this lecture once again, or probably it's recording once again, and look look for the slides where I explained this grid dims and block dims and all those things. There probably you'll be able to get the better idea of it. So when I say grid dim, it's the dimension of grid, and when I say block dim, it's the dimension of the block, and those are the fixed numbers. Those numbers won't change across the
Sir, one doubt, sir. When you say like dimension of the block, you mean like the number of threads in that block, like that you mean, sir?
See, it's not number of threads in that block. Dimensions are determined by the way you are launching the kernel. Here you are explicitly saying that I want a block with uh, x dimension as 5 and y dimension as 6. So it's not number of threads, it's the dimension that you are specifying here. Number of threads are 30, right? But block dim.y will give 6. So that 30 and 6 are not same. So number of threads and the dimension is different thing. Dimension is something that we specify as a programmer, as well as threads also are specified by us only, but both the things are different is what I'm trying to say. I hope that's clear.
I've understood somewhat, sir. I got.
Yeah, I mean it's completely okay not to understand it in first go, because these concepts are quite tricky, I would say. If you go through the recordings couple of times, one time more or probably one or two times more, I am sure that you will be able to get it. Yeah, but if you still have any question, then you're free to mail me or post in the group or something, so that we can take it up from there, right?
Yes, sir.
Okay. If there are any other questions, let's see here. Yeah, please go ahead. Yeah, you are audible.
Please go back to.
Yeah.
Sir, me audible now, sir?
Yeah, you are audible. But your
Sir,
voice is breaking.
here sir, with noise or without noise, sir? Is this clear?
Yeah, there is no noise, but your voice was breaking. Please go ahead. Yeah, I'll try to understand what you are trying to say.
We have mentioned thread ADX.x and others are in Y, sir. But I saw something like thread ADX.x into block dim.x plus block ID idx.x like that. My question is how to mingle this x, y, and z dimensions to get the unique thread ID, sir. Here for 2D, it's like you are using x and y, sir. Or is this the fixed one, or we can change to as per our program need, sir. This is
Yes.
my question. It's like we need to get the unique thread ID. This is a 2D program. We use in this way. For 3D or 1D, we can change, right? Or is it a fixed one? Or is there any formula? Is there any way to arrange this x, y, z dimensions? Maybe here z dimension is 1, but it may if it is instead of 1, if it is 3 and all, should we consider those z dimension in unique thread ID?
Yes.
Fine, sir.
Yes, you are correct. I mean, if you are using, let's say if you are using more thread blocks here instead of one, then in that case you also need to consider the thread block, I mean, to get the unique ID across the threads, right? So it depends upon how we are launching, and it also depends on how you are defining the dimensions. So these two things you should always keep in mind for calculating the ID uniquely. I hope that's clear.
Yes, sir. It's clear now. If I get any doubt in future, I'll ask you in personal, sir, in mail and all. Thanks.
Sure.
Carry on, sir.
Yeah, so I'll cover one more slide and then we'll stop, because I think we have already reached the time 6:30. So I'll just cover one more slide. I'll skip. Yeah, so I want to cover this slide because this is quite important one. So as we did for two-dimensional data structure, I mean two-dimensional matrix. Two-dimensional matrix. Actually, matrix was just one dimension. They were accessing it in two-dimensional way, and we were launching a block which was having two dimensions, right? In the previous case. Now instead of that, let's say everything is same, right? Like n is hash defined as 5 and m is hash defined as 6, and then we have these two pointers similar as the previous program, and then the memory is allocated, and then on the GPU and then on the CPU, and everything is same. But now the difference is that instead of just launching the kernel with one block, we are launching the kernel with 5 blocks, and inside each block we have 6 threads, m threads, which is 6, and we are passing this matrix, and again after that we are copying the matrix back and printing it. Now we want to initialize the matrix as we did before, and yeah, we want to write the kernel to initialize those matrix to unique IDs. Now I want you people to quickly try out how can we do that, or probably I'll just wait for 1 minute and then I'll quickly explain what should be done. Yeah, sorry, I'll just wait here.
Could you tell the question again, sir?
Yeah, so instead of in the previous case we launched the kernel with just one block. Instead of that, we are here launching kernel with n blocks, 5 blocks, and inside each block we have 6 threads. And in this case, blocks are not two-dimensional, it's one-dimensional block, right? We are not using dim2 or dim3, anything of that sort, right? We're just passing integers as parameters here, right? You can see. Then and again we want to initialize the kernel as we did before, and I want you people to think how can we do that quickly. I mean, just this last slide I want to cover, and then we'll finish for today. So the main question here is like, how will you calculate that ID uniquely is my question, such that we can get all the numbers from 0 to 29 as we did in the previous example, right? I'll just wait for a few more seconds and then explain. Okay, let me go to the chat. Okay, thread idx.x plus into thread idx.py looks correct. We'll need to see. Where the thread requirement is 30 block involved is for each block executes 6 thread. Here the pro. Okay. Yeah, that's correct. Block 0 will have 0 to 5 threads there. I mean 6 threads per block. Block idx.x into m plus thread idx.x. Okay. Block dim.y. Okay, so I guess most of, I mean, some of the answers are correct, I can see, but I'm happy that many of you are trying it. Okay, so let me quickly go back to the slides because we are already run out of the time. So, okay, here, if you see, this is the correct equation. This is one of the way in which it can be done correctly. There can be multiple ways. So, let's try understanding this. So, first of all, one thing that you should observe here is there is no y and z dimensions here that you should fit in your mind, like, because we are just launching the kernel with the grid dimension as 1 and block dimension as 1. There is no y and z dimensions involved here. So accessing y and z here is like, there is no point of doing that, right? Because grid has 1 dimension and block has 1 dimension. So that is first point that you should know. Now, in order to get a unique ID for each thread, how can we do that? So first of all, if you see this equation, you'll see that there is a block dim x.x. Now, what is block dim x.x? Block dim x.x is again the dimension of that block in x direction, and there is only one direction in this case. So in this case, the block dim x.x will give 6, and block ID x.x will go from okay, so for it will go from 0 to 5 because we have 5 blocks, so 0 to 5, and inside each block we have 6 threads. So thread ID x.x for each block, for remember it, for each, please note it, that for each block thread ID x.x will go from 0 to 5 because there are 6 threads, and block ID x.x will go from 0 to 4 because there are 5 blocks. For each block, it will go from, again, for each block, thread ID will go from 0 to 5 because there are 6 threads in the block, and there are 5 blocks. So block ID x.x will go from 0 to 4, and block dim x.x will be a fixed number, which is 6. So yeah, so in the similar way, similar manner as I explained in the previous example, for the thread 0 of the block, first thread of the first block, let's take it in this way. For first thread of the first block, block ID x.x will be 0, thread ID x.x will be 0, so the ID computed will be 0 into 6 plus 0, which is 0. For the next thread of that same block, the block ID x.x will be 0, thread ID x.x will be 1, so 0 into 6 plus 1 is 1, and so on for the sixth thread, which will have thread ID x.x as 5, and its block ID is 0, so 0 into 6 plus 5 is 5, and so on for the other threads of the different blocks. And for the last block, it will be 4 into 6 because last block is the fourth block, right? Blocks are from 0 to 4 because 5 blocks are there from 0 to 4. So for fourth block, it will be 4 into 6 plus 5. So 6 4s are 24 plus 5 is 29. So the last ID will be 29. So 29th location will be initialized for 29. and the output will be same as the previous one. And the key point to observe is that the key takeaway that you should observe from this slide is that the thing that you can do with the multiple dimensions, in fact, that we saw that using 2 dimension we did the same thing, right? We can do it the same thing using 1 dimensions also. So like here we are using just 1 dimension, right? Thread and blocks are of just 1 dimension. Sorry, not thread and block. Grid and blocks are just of 1 dimension. But in the previous case, it was block was of 2 dimensions. So anything that can be done with 2 dimension or 3 dimension can also be done with 1 dimension. And a quick question for you: if we want to launch the kernel using 2 comma x, here let's say instead of n it's 2 comma x, then what that x should be? Probably with this is the last question. With this we'll end today's lecture. Yeah, so again I'll repeat. If we, instead of this m comma n, if we want to, everything is same, like rest everything is same, and we want the same output for this program. But let's say we replace this m comma n with 2 comma x. Here some x is some number. Then what that x number should be, such that the output remains the same and the entire code, rest of the code is the same. What that x should be? Yes, that's correct. 15 should be there, because at the end we want to launch the 30 threads, right? To initialize this matrix, and hence it should be 2 comma 15, and that will give the correct, correct results for this code if we change this part. Right? Yeah. So with this, I'll end. Probably today I overshot, but yeah, if you have any questions, then you can ask it right away. I'll be still there here for 5 minutes. Otherwise, we'll stop here.